Okay, today we're going to look at adding and subtracting radicals and kind of figure out how we need to do that. So to start with, let's look at just a basic question and see what we think could happen. So we have 4 times the square root of 3 plus 2 times the square root of 2. What some people would do is think, well, because we're adding them, we can just go 6 root 5. We can just add the front numbers. The 4 plus 2 is 6, and the root 3 plus the root 2 is root 5. So that's a common thought, but if we actually try these out on a calculator, you'll see that it doesn't work out. So if you do 4 times root 3 plus root 2 times root 2 times root 2, you get 9.75, and then when you do the other side, you get 13.4. So that means these are not the same. So you can't add the numbers just like that. You can't just say, well, I just add the front numbers, add the root numbers. So let's try a different one. Let's try if I went 4 root 3 plus 2 root 3. And a common belief in this case is we still would add the front numbers, the 6, but we leave the root 3 by itself. So if you try those on a calculator, do both sides. If we go 6 times root 3, we get 10.39. We do the other side, we get 10.39. So this one is true. So as long as the roots are the same, we can add them. So we can add front numbers if the root numbers are the same. Okay, but you can see we don't change that root number. So 4 root 3 plus 2 root 3, we put them together to get 6 root 3, but the root 3 part stays the same. Okay, so kind of the key thing to remember then is we can't add if they have different roots, but we can add them if the roots are the same. And then we only add the front numbers. A good way of sort of thinking about this is it works exactly the same as regular algebra. So if I gave you 4x plus 2x, as long as they're both x's, we can add the front numbers, we'd get 6x. So if I gave you 3x plus 2y, we can't add those because the x and the y are different. So it's the same sort of logic for the square roots. The only thing that's different is instead of having x's or variables, we just have roots this time. So we have root 3, root 2, root 5, those types of things. So the process then is basically that simple. As long as you have roots that are the same number under the root, and they'd have to be the same index on the root, so you can't add a square root with a cube root. As long as they're both the same, exactly the same, then you can just simply add or subtract the front numbers. So let's do a simple example here. So if I gave you 4 root 6 plus 2 root 6 minus 3 root 6. Okay, so you can see it doesn't matter whether we're adding or subtracting, we just simply add or subtract the front numbers. So in this case, 4 plus 2 is 6, minus 3 would be 3. So our final answer then is 3 root 6. Okay, and like I said, as long as the roots are the same, so we could do 4 cube root of 2 plus 5 cube root of 2 minus 2 square root of 2. So in this case, we've got to be careful because they're square roots and cube roots, so these two can go together, right, because they're both cube root of 2, but the last one can't. So in that case, then we just put the 2 together, so you'd have 9 cube root of 2 minus 2 square root of 2, and you just leave your answer like that. So if parts of the question can't be combined, you just leave them separate. If they can be, then do so. And it works the same if you had different numbers. So if I gave you 2 root 3 plus 4 root 2 minus 5 root 3 plus 2 root 2. So in this case, you got to be careful. We got root 3, so the 2 root 3 and the minus 5 root 3, those can go together. So I'd give you negative 3 root 3. And then the root 2's, we got a 4 root 2 and a 2 root 2. Those two can go together to give you 6 root 2. Okay, so that's basically the process for adding and subtracting radicals, which is pretty easy, and I think that Most people understand that pretty good. The hard part is what happens when the radicals are different and you can't put them together. So something like this, if I give you root 8 and root 32. So using kind of what I just told you on the previous page is if the numbers are different, we can't add them. So you'd say, well, we can't, it just stays the same. But what you got to be careful of is sometimes you're going to have to simplify. So if you simplify first, then maybe you can still add or subtract them. So in this case, what we want to do is using our square root chart, just like we did before. So if 2 is square root of 4, 3 is square root of 9, 4 is square root of 16, and so on. I'll just do a few of them just so we have the numbers handy. So if you look off your square root chart and you try to simplify these, sometimes that'll make the question possible. So if we take the root 8, we simplify it into 4 and 2, right? Because 4 is one of our perfect roots. So that'll simplify down to 2 root 2. And if we take root 32, we change that into 16 and 2. So that'll simplify to 4 root 2. So now, because they're both root 2's, after we've simplified them, now we can add or subtract, so we get minus 2 root 2 for this one. Okay, so that's the hardest part with adding and subtracting is it's really nothing to do with the adding and subtracting, it's you have to be able to do the proper simplifying that we've been working on for the last few days. Okay, so let's try one more example and then we'll stop there. So if we have, let's do 2 square root of 24 and plus, or let's do a minus 3 square root 150. Okay, so the same kind of question. When you have a number in front like that, nothing changes. You just basically think of it as being times. So we leave the 2 out for now. The root 24, we're going to simplify it down to the biggest root that would go into it would be 4. So we'll have 4 and 4 times 6. And then we do the same thing with 150. So that would be 5 times 6, or 25 times 6. So 25 is our biggest root. So that'll be the simplified version. And then remember, these are just being multiplied. So we basically would get 2 times, because these are all being multiplied together. So 2 times regular 2 times root 6. And the second one would be 3 times 5 times root 6. So we just multiply those front numbers. So 4 root 6 minus 15 root 6. Now they're both the same roots. We can add them together to get minus 11 root 6. And we're done. Okay, so we'll stop there. Like I said, the hardest part with this stuff is doing the simplifying. So if you're having trouble with that, go back and review how to do the simplifying stuff that we did earlier.